Okay guys, I'm going to do a problem that's very similar to one of the problems in the book. What we've got here is the challenge to find the equation for a circle. We're looking for a circle and its equation that circumscribes a triangle with these three vertices. Alright, so I'm going to plot those three vertices. We've conveniently chosen one of them to be the origin. Another is over 10 up 12, so about there, that's point B. And then our third is over here at 16, 0. So here's my triangle like this. And I'm looking for the circle that touches all three of those vertices. Well, the concept that we're dealing with, you should perhaps remember from last year, is that if we have a circle and we have any 2 points on the circle, that if we construct the chord and then the perpendicular bisector to that chord, so that's equal to that and that's perpendicular, that the center of the circle lies somewhere on there. And if you think about a piece of paper and folding it in half, you can imagine that that is in case the fact. So if this point and this point were joined and we did a perpendicular bisector as well here, we would get a second line that would go through the center, and then where these two lines intersect is the center of the circle. So we're going to do that with our triangle. We're going to find two perpendicular bisectors for the three sides. So you can choose which two you want, and we certainly could do this side and this side, but it's much easier to use the side that's oriented along our axes. So you'll see in the book that's also the case. So the perpendicular bisector for this side that goes out to 16, 0 is going to go through a midpoint right here at 8, 0, and if it's perpendicular, it's going to be vertical like that. So we know that the equation for this line is just x equals 8. That whatever happens, it's going to be an x-coordinate of 8. A little bit more challenging is finding the perpendicular bisector for either this one or this one. And it really doesn't matter. I'm going to pick this one here. And so this segment here, the midpoint, I can find that midpoint by averaging the x's, 0 and 10. That gives me 5. Averaging the y's right here, 0 and 12. That gives me 6. And so that's the coordinate for that point M right there. All right? Well, to find this perpendicular bisector then, I'm going to need to find the slope of this and then do the negative or opposite reciprocal of that. Well, the slope is just going to be over 10 and up 12 to get to this point. So that's a rise of 12 and a run of 10. That's my slope, which simplifies to 6 over 5. I could have just used this point as well. But if that's my slope, I can put that into point slope form. And the easiest point to pick, of course, is the origin right there. So my equation for, well, I don't need the equation for this line. All I really need is the negative reciprocal slope, because this slope here, m, is going to be equal to negative 5/6. That's the slope I need. And the point that I can put it through is this one right here. So putting it into point slope form, it'll be y minus 6 equals negative 5/6, then x minus 5. And that's my equation in point slope form, which I guess I'll put it into slope-intercept form. If I distribute this and distribute that, it's not going to be pretty, but we'll make it work. Y minus 6 equals negative 5/6x, and then plus 25/6. When I add 6 to both sides, that's adding 36/6. And so my final answer here is y equals negative 5/6x plus, and then this is going to be what, 61/6. So I get 10 and 1/6. This equation and then this equation for my two lines. I want to find that point of intersection. So I can just put in x equals 8 right here. I'm running out of room a little bit, but I'll squeeze it in down here. Y value then is going to be equal to negative 5 over 6 times 8 plus 10 and 1/6. Okay, you can pause it and do the math. Maybe I'll edit out the calculation here, but 8 times 5 is 40, so it's y equals negative 40/6, and then plus, and I can go back to 61/6, and I will get 21/6. 21 over 6 is exactly 3.5. So this coordinate here for my center is 8, 3.5. All right? Now that I've got a center, the equation for a circle, I'm going to erase this up above. The equation for a circle is that r squared, the radius squared, is going to be x minus the center, whatever the center coordinate is, squared, plus y minus the coordinate, the y coordinate for the center, squared. So I need to know what this distance is, okay? Well, the distance here to the origin from this point is just going to be each of these coordinates squared. So r squared here, this radius, is going to be 8 squared plus 3.5 squared, square rooted, to find the radius. But of course, when we square it, it'll go back to being this. And then x minus the x value is 8 squared plus y minus 3.5 squared. All you need to do is the math here. 8 squared is 64. 3.5 times 3.5 is, I think, 11.25. I'm just doing that from the top of my head. Let's hope I'm right. 11.25. If that's in fact the case, it'll be 75.25. So 75.25. You can check with your calculator and see how good my mental math is there. All right? But that would be the equation for a circle that has that as the center and that as the radius. And if you do it properly, it'll swing around and go through, whoops, that's bad aim, swing around and go through all three of those vertices like that. Okay, thanks. Good luck.